In section 5.2, we'll look at systems of linear equations with three variables. In particular, we'll identify solutions to the systems, solve the systems with three variables, and then use the system in an application. So the same rules apply as before. If you want to determine if a ordered triple is a solution to a system of equations, it has to satisfy all three equations now. Example 1. Determine if 5, 3, negative 2 is a solution to this system. So we'll just check it in each of the equations. So we get 2 times 5 plus 5 times 3 minus negative 2 is equal to 27. Maybe. And so that would be 10 plus 15 plus 2 might be equal to 27. And yes, 10 plus 15 plus 2 is 27. So that one works out. Let's check it in the second equation. Bless you. 4 times 5 minus 3 minus 2 times negative 2 might be equal to 21. So this would be 20 minus 3 plus 4 might be equal to 21. 20 minus 3 is 17, plus 4 is 21. So check. That one works. And then verify that it works in the last equation. Notice that this one is missing the y. That's okay. We just skip the y. We get 5 times 5 plus 3 times negative 2 might be equal to 19. So 25 minus 6 might be equal to 19. And yes, 19 is equal to 19. So is it a solution? Yes. 5, 3, negative 2 is a solution to the system. So just remember, it has to work in all of them. If it fails to satisfy any of the equations, then it is not a solution to the system. All right, example 2, solve this system. So all of the stuff that you know before is still in play. So I'm going to start with substitution. I'm going to solve the top equation for z. And that would be z is equal to 7 minus 3x minus 4y. Then I'm going to take this solution and I'm going to plug it into the bottom two equations. So we're going to have negative z plus 2y plus 3 times, and now I substitute the z, 7 minus 3x minus 4y equals 1. And we plug it into the bottom equation as well. 6x plus 5y plus 9 times 7 minus 3x minus 4y is equal to negative 9. Now notice what you have. You have two equations left in the system and two variables. That's perfect. If it works, it's going to work with this right here. And you're basically back down to the stuff from the last lesson. All right, so let's simplify. So we're going to have negative x plus 2y plus 21 minus 9x minus 12y equals 1. And the bottom equation, 6x plus 5y plus 63 minus 27x minus 36y equals negative 9. let's simplify the equations, combine the x's, combine the y's, and then combine the numbers on the other side. So here we have negative x minus 9x, that's going to be negative 10x. Two y minus 12y is negative 10y. And 21 moves over to the right as negative 21, adds to the 1 and gives me negative 20. Let's add the x's and y's together on the bottom equation. 6x minus 27x is negative 21x. 5x minus 36x is negative 31. Sorry, those are y's. 5y minus 36y is negative 31y. And then move the 63 to the other side. It's negative 72. Now, let me show you a little trick that'll make some of the equations easier to work with. Notice that this top equation, all of the coefficients are multiples of 10, and they're all negative. You can scale equations up and down as much as you would like. They're still going to be consistent with the equation. So, I'm going to multiply this equation by negative 1/10. Just because. And it'll make it smaller and easier to work with. So that's going to be x plus y equals 2. See? Much better. We still have negative 21x, negative 31y, and negative 72. In fact, I'm going to go ahead and multiply those. Let me just go ahead and do that real quick here. I'm going to multiply those by negative 1. So that's going to take out the negatives from each of these. It's going to make them positive. You don't have to, no. But it's just personal preference, you know. Okay. Now let's do some addition and elimination. So what could I multiply this equation by to get rid of the y's? I'm going to multiply it by negative 31. Okay. So this now becomes, I'm going to put it up here now. There it is. So this is now negative 31x minus 31y is equal to negative 62. The bottom equation stays the same. And then you can add these together to get rid of the y's. So this is going to be 10x, negative 10x rather, is equal to positive 10. And so x is equal to negative 1. So we found one of the variables. 2 more variables to go. Now, remember that as we are working with these equations, every equation is still consistent with the entire solution. So I can plug in x equals negative 1 into any of the other equations that I like. In particular, I like this one here. So I'm going to plug in negative 1 into that one. So negative 1 plus y equals 2, and so that's y equals 3. Some students feel like you have to go back to the original equations to do things. No, you do not. All of the equations are consistent, so they're all good. Use any of them. So there's y equals 3. And now, the one equation that we have left that is perfect for finding the z variable is the original substitution equation. So z is equal to 7 minus 3 times the x, which was negative 1, minus 4 times the y, which was 3. and that's z equals -2. So the solution is an ordered triple, -1, 3, -2. All right, example 3. Find the equation of the quadratic function that passes through the points -4, -21, -1, 3, and 3, 7. So your basic quadratic function looks like the following. Y equals ax squared plus bx plus c. If you're going to determine the equation of this quadratic function, you need to find the a, the b, and the c. We have 3 variables. In order to solve for 3 variables, we need 3 equations. So what we're going to do is we're going to create the equation based on the 3 points that we are given. So from this first point, -4, 21. -21 is the y, and -4 is the x. So it's going to be a times -4 squared plus b times -4 plus c. For the second equation, we plug in the second point. So we get 3 is equal to a times -1 squared plus b times -1 plus c. And then the third one. 7 is equal to a times 3 squared plus b times 3 plus c. And there's your system. All right, so let's simplify the system a little bit. I'm going to switch everything back around so that the variables are on the left and the constants are on the right. So this is going to be 16a minus 4b plus c is equal to -21. Right, switching them around. The next one would be a minus b plus c equals 3. And then the last one is 9a plus 3b plus c equals 7. All right. So let's attack this one again, same way we did the last time. I'm going to start by solving one of the equations for one of the variables. I choose to solve the middle equation for c. So c is equal to 3 minus a plus b. And I'm going to substitute that into the other 2 equations to create another system of 2 equations and 2 variables. So subbing into the first equation, we get 16a minus 4b plus 3 minus a plus b equals -21. And then 9a plus 3b plus 3 minus a plus b equals 7. So we substituted into the c there, and we come up with these 2 equations with 2 variables. All right, let's combine. So 16a minus a is 15a. -4b plus b is -3b. It's equal to -21. No, hang on. 24. My bad. All right. And then 9a minus a is 8a. 3b and b is 4b. And 7 and 3 is 4. 3 comes over as a negative. Okay. All right. So again, I'm going to do this optional step. I'm going to scale everything down. Notice that the first equation is a multiple of 3, so I'm going to multiply that by a third. The second equation is a multiple of 4, so I'm going to multiply that by a fourth. You're also just basically dividing. So it's going to be 5a minus b is equal to negative 8. And then 2a plus b is equal to 1. And that would actually turn out really good because you see that we have opposite b's. We have minus b plus b. So I can just add this one straight down and it's going to cancel off the b's. So we get 7a is equal to negative 7. And so a is equal to negative 1. Then I'm going to pick up this equation right here. And I'm going to solve for b. So 2 times negative 1 plus b is equal to 1. So that's negative 2 plus b is equal to 1. And so b is equal to 3. And then I'm going to use this original equation. I'm going to get c is equal to 3 minus negative 1 plus 3. So c was equal to 7. And so then the question is, what was the quadratic? So it was negative 1 times x squared. So that's negative x squared plus 3x plus 7. And so that is the quadratic that goes through all 3 points. There is this general rule in math that says if you need a function of degree n, you need n plus 1 points. So for degree 2, you need 3 points. That's exactly what you have.